Hi students, welcome to my lectures on chemical engineering thermodynamics. I request you to follow my lectures from the beginning because every lecture is connected. In the today's class, we are going to discuss about the finding out saturation pressures and saturation temperatures. If you go back to the one class back or two classes, we were discussing about the Raoult's law, Henry's laws. So in those laws, it is always required to find out saturation pressures of different components. When we mention the saturation pressures, that means I am talking about the pure components. Okay, sometimes you need to find out what is the saturation pressure, what is the saturation temperature of a particular component, because it goes into the calculations. For example, if you refer to the board, you can see there are some molecules A and B existing in the vapor phase as well as the liquid phase. Finally, the agenda is to, at a vapor liquid equilibrium, that means if both phases are present, then our objective is to estimate how much A is in the vapor, how much B is in the vapor, how much A is in the liquid, and how much B is in the liquid at certain temperatures and pressure conditions. That means obviously you have to apply some laws to find out. One such a ideal law is Raoult's law. Raoult's law states that Yi into P is equal to Xi into Pi saturated. If the molecule A, it is called Pa saturated. If the molecule B, it is called the Pb saturated. What is Pa saturated and Pb saturated? These are the pressures of pure A at this particular temperature. That means you have to fix the temperature because temperature is at the utmost importance. Again, for example, there is a specific temperatures and pressure in which the mixture is existing. And to apply the Raoult's law, you have to find out what is the saturation pressure of pure A at this temperature and what is the saturation pressure of pure B at this temperature, because that's what goes into the calculations. Pa saturated and Pb saturated, you can think of boiling points, okay, and condensation point. Example, water evaporates at 100 degrees centigrade. If there is a liquid water, if you try to put heat, okay, add heat into the water, so, and at 100 degrees centigrade it will evaporate. Okay, that means you can find out vapor and liquid at 100 degrees centigrade. Okay, similarly, if you have a water in the vapor state, and what happens, what temperature it will condense? It will condense at 100 degrees centigrade at 1 atmospheric pressure. That means this T saturated is 100 degrees centigrade, P saturated is at 1 atmosphere. You can see that means at a specific temperatures and pressures, both vapor and liquid existing for the pure cases. Okay, of course, if it exists for every case. So what is this Pa sat? Pa sat I am talking about at this temperature, what is the saturation pressure? The saturation pressures in other side, at what pressure the A and A molecules in the vapor state will be existing along with the A molecules in the liquid state. Okay, at what temperature? Suppose we are discussing about this mixture and we need saturation pressure of A. The saturation pressure of A is nothing but at this temperature, what is the pressure of A such that liquid and vapor both exist for a pure state. Similarly, what is the Pb saturated? Pb at this temperature, that this mixture temperature, at what pressure the molecules of B will exist in liquid as well as vapor state. Okay, that is what at this temperature Tb saturated, this is what the Pb saturated. There is a relationship always exists. If you change the temperature, saturation pressure will change. If you change the pressure, saturation temperature will change, because in thermodynamics the utmost importance is given to the temperature. Finally, we will fix the temperature. At this temperature, what will be the saturation pressure of A? Okay, what is the saturation pressure of B? Then how you are going to estimate? There are some Antoine equations, okay, Antoine expressions. From the Antoine expressions, you can able to estimate, if you provide the temperature, it will tell you this is the saturation pressure for A molecules or B molecules, and whichever may be the molecules that are there in the mixture. If you wanted to find out what is the pure boiling points of A, pure boiling points of B, you can get it from the Antoine expressions. That means saturation pressures and saturation temperatures. Let us apply, let us discuss about what are Antoine equations. Antoine equations are there where pressures and temperatures are related. If you know the temperature, you can calculate the pressure. If you know the pressure, you can calculate the temperature. You can see this is explicit expressions for pressures. This is explicit expression for temperature. If you know the temperature, you can calculate the PI. PA is at. If you know the pressure, you can calculate the temperature. Anything, vice versa, you can do. Okay. And these are Antoine A, B, C. Okay. A, B, C are constants for a certain component. Okay. Let us example, there are two components. Okay. Acetonitrile. Okay. Example. What is the constants of acetonitrile? Is A, B, C. There will be existing constants that are given in the textbook. Okay. Only thing, if you put the constants of those particular molecules, A of acetonitrile, B of acetonitrile, C of acetonitrile, and temperature of interest, you can calculate what is the saturation pressure of acetonitrile. Similarly, there are different constants given in the various textbooks. Only thing you need to put is, majority of the students do the mistake that what is the unit you should supposed to take, because there are different textbooks comes with equations slightly variable, and you need to find out if you are using this particular equation, this capital T temperature should be given in Kelvin, and whatever you are going to get the value of the pressure from this equation will be in kilopascal. Similarly, if you give the value of pressure in kilopascal here, given A, B, C constants of that particular component, you can calculate what is the saturation pressure of that particular component. Same expression, this T will be in Kelvin and small t will be in degree centigrade. That is why minus 273.15 you are going to get. Okay. So using these Antoine equations, you can able to calculate what is PSat and PBsat. Okay. So let us say for a molecule A, example, if you are doing this kind of binary mixture, for molecule A, saturation pressure of molecule A is nothing but constant A of molecule A, constant B of molecule A, constant C of molecule A. Similarly, if you wanted to find out the saturation pressure of B, you have to give constant A of molecule B, constant B of molecule B, constant C of molecule B. Okay, A and B are different molecules. Okay. Let us find out a small example. Okay, so you will be understanding much more. Okay, let us see, there is, let us not talk about the mixture. You wanted to find out the saturation pressures of temperatures of two things. One is acetonitrile, pure acetonitrile, and pure nitromethane. There are two things existing in two different containers. You have to find out at a given temperature. Example, temperature is given at 75 degrees centigrade. What is the saturation pressure of acetonitrile and what is the saturation pressure of nitromethane? And A, B, C constants of acetonitrile and nitromethane are provided. So let us apply the Antoine equations to get at 75 degrees centigrade what is the saturation pressure of acetonitrile. At 75 degrees centigrade, what is the saturation pressure of nitromethane? So I will apply the formula, and A, B, C of acetonitrile, I will put it in this particular equation. Once I get the then, and the saturation pressure of A, which is nothing but acetonitrile, is 83.21 kilopascal. Similarly, if I give the constants of A, B, C of nitromethane, I'll get the saturation pressure of nitromethane at 75 degrees centigrade. I'm talking about pure things, 41.98 kilopascal. In summary, at 75 degrees centigrade, the acetonitrile pressure is 83.21. At 75 degrees centigrade, nitromethane pressure is 98 kilopascal. Can you able to guess which one is more volatile? More volatile means the boiling point will be less at that particular pressure. Don't worry about it. You're going to get the clarity in the future videos. You imagine there are two containers. One is of acetonitrile at 75 degrees and second is nitromethane at 75 degrees. Which one is more volatile? That means which one is more easy to evaporate? The one which creates the high pressure at the same temperature, that is more volatile in nature. What is the means of volatile? That means liquid has a more tendency to evaporate, okay, and create some pressure, okay. And you can see the saturation pressure of acetonitrile is 83.21 kilopascal. Then it is creating more pressure compared to nitromethane, which is 41.98 kilopascal. That means the one which is trying to create the more pressure will be more volatile component, and the other one is less volatile component. Hope now you understand that how to calculate the saturation pressures and temperatures. Okay, well, let us meet with the new lecture. See you.